Hello, folks. This is the CD that comes in the back of the textbook. This is the one that I use to teach in class. Um, there's the main menu. Some of you probably weren't able to install this. Um, you need a Windows computer in order to do that. You had to have a CD-ROM drive, or you had to be able to take the information that I posted in Google Classroom and then transfer it to your hard drive. So there's some technical issues here. Not everybody is able to do these things. So I'm going to go through the disk and go through the sedimentary rock section, make a recording of it, and then you can kind of experience the disk with narration the same way that I do in class. So all of the minerals and rock types, igneous rocks, sedimentary rocks, metamorphic rocks, are all classified under earth materials. We've gone through the minerals, we've gone through the igneous rocks, we've gone through the rock cycle, and now we're into the sedimentary rock. Well, we had that completed, and now we're into the metamorphic rocks. So I'm just going to run through the sedimentary rock stuff here. And so this is just like a rehash of the rock cycle and the fact that, everything starts out, it's initially magma, igneous rock, that breaks down into sediment, the sediment turns into sedimentary rock, the sedimentary rock can metamorphose, the igneous rock can metamorphose, the metamorphic can turn back into sediment. So it's all, it's even more complicated than you see here. And that process where weathered bits of existing rock are turned into sedimentary rock is called lithification. So a little bit of notes about weathering. That's the breakdown of rock into sediment. And it can be physical, which is simple smashing, or it can be chemical, which is where things in the atmosphere like oxygen, carbon dioxide, water, salts, all of these things will degrade rocks and make them weaker. So just a little bit of information here on the physical weathering. It could be, it could be ice, it could be running water, it could be just gravity. But all of these things smash rock, create more surface area, and so here's a talus slope. That was one of the questions on the I think it was in the crossword puzzle. That's where you have just like a whole bunch of debris of weathered material from the mountains just tumbles down a valley and makes this big slope of angular rock fragments. And the fact that it's angular means it will turn into something like breccia if it was turned into sedimentary rock. And there's chemical weathering that can only attack the surface. And the cool thing about physical weathering is that it exposes more surface area for chemical weathering to attack. And so here's your granite. That's kind of like the foundation of the continental crust. It has feldspars, quartzes, micas, hornblende, which is amphibole, and everything except the quartz will chemically weather into clay minerals and ions. The quartz will fall out as sand grains because it does not chemically weather, and it's the hardest of all of these minerals. So everything else will just turn into clay and ions, and the quartz will turn into sand grains. This you don't need to know. So the clay minerals, that comes from the chemical weathering of all of the non-quartz minerals in granite. And then here's some ions like potassium, silica, calcium. All of these things come out of the granites as well. And then these are the quartz crystals in granite. They come out and they will eventually turn into sand grains. Sand can accumulate in deserts, on beaches, and riverbeds. And so here's the erosion bringing stuff. And so these are different places where deposition occurs. Deltas, dunes, moraines, beaches. These are all places you would find sands. This would be a gravel because it's all different size particles. The beaches would be mostly sand. Deltas could be mud, could be sand. Lithification, those are two processes that turn sediment into sedimentary rock. One is compaction. That occurs with mud, like just ordinary mud, or it could be calcium carbonate mud, will compact into sedimentary rock just because of all the pressure on top of it. And the other one is cementation. That's where you have sand and pebbles that, as water is passing down through them over thousands of years, minerals will come out of solution and eventually fill up the spaces between those particles and cement them together like a glue. And so these are the clastic sedimentary rocks: shale, sandstone, conglomerate, and also breccia, which is the angular equivalent of conglomerate. And then we have our chemical sedimentary rocks, things like this rock salt. And so here we go. These are the clastic sedimentary rocks deposited, um, mud, sand, pebbles, all of these things. So here you have like a cutaway from a riverbed where you have alternating layers of gravels and then muds. And these are telling you that the river was flowing at different speeds. When it's slow, mud can drop out and get deposited. And then when it's fast, it will only deposit things that are heavier, like pebbles. They will get laid down in a fast-moving stream, and all the mud will just get carried away. So here we go. Just like clay, mud, sand, pebbles. That's the difference. And here we go. So there's your gravel, conglomerate or breccia from gravels. And there's a breccia, all angular pieces. And the sand becomes sandstone, and the mud becomes shale or mudstone. The shale is quite soft. It's not cemented together, and so it tends to crumble and turn into soil or get covered by vegetation very easily. Whereas the other kinds of sedimentary rock, like the conglomerates and the sandstones, are tougher and they don't weather away as easily. The chemical sedimentary rocks all come from ions. It could be silica, it could be calcium carbonate, it could be salts. Those are chemical sedimentary rocks, like the salts. There's an inorganic process in these evaporate deposits, or there's a chemical process, like this would be a biochemical sedimentary rock, coral. Limestone, so that's all calcium carbonate. This is lithified calcium carbonate that would have been in tropical seas, like the kind of white mud you see in tropical seas today. That will eventually turn into limestone. Most of that stuff is organic. It's organic material, like little microscopic calcium carbonate shells. Some of that stuff is large calcium carbonate shells, in which case we call it coquina. And if that calcium carbonate mud has not completely turned into like a hard limestone, it's referred to as chalk. And these are made from the microscopic calcium carbonate shells of plankton. Coral, another form of limestone, and here you can see the pattern of the coral in the rock. It's all calcium carbonate. And here's a travertine, which is deposition of calcium carbonate in cave deposits, and that's always inorganic. This doesn't form from living things. And then we have these silicas, which are called cherts. These are from the silica shells of single-celled algae in the oceans called diatoms, and they accumulate in the sediment, and they will eventually turn into things like flint. And the examples we had in our class look just like this. And then we have the evaporate deposits, which are like the salt flats in the desert, the evaporation of seas like the Mediterranean or the Dead Sea or the Aral Sea. They leave salts behind. Or it could be gypsum, which is calcium sulfate. That usually gets laid down first, and then the salts will get laid down on top of it. And so here's a salt flat in Death Valley. And then we have this quiz here. Rock with angular gravel-sized particles. That's going to be breccia. And then jasper and agate. That would be chert. And then we have limestone with an inorganic origin, would be the travertine. The feldspar-rich sandstone, we don't discuss this one. That's not part of our course. Limestone composed of shell fragments. Evaporite rock rich in halite. Rock salt. Halite is salt. Clastic rock rich in silt and clay-sized particles would be shale. And here we now have sedimentary features. That was kind of abrupt. Stratification is the feature where sedimentary layers are laid down in beds. They're stratified. Each layer is unique. It's telling you something about the deposition conditions that cause that sediment to get laid down. It could be wind blown. It could be deposited by water, fast moving water, slow moving water. The wind could be coming from different directions. And here's some other kind of features: fossils, cross-bedded sandstone, ripple marks. There's the cross-bedding occurs in sand dunes because the wind is changing direction over the course of the year and laying down the sand grains at different angles, depending on the prevailing wind. The ripple marks, this is it could be like waves going back and forth or a current. Mud cracks, that's only going to occur in places like tidal flats where it periodically dries out. Fossils, we went through some of the different kinds of fossils in the handout that I gave you. So here, I don't think we did this in class. Like this is a little quiz. It says where would you find breccia deposited? And angular particles like this, swamp, landslide, sand dune, beach. Well, you're going to have angular, sharp fragments in a landslide. They're not going to be rounded because they haven't been transported anywhere. The shale with mud cracks you would find in a tidal flat, right? Because it's all mud and it has mud cracks in it because it periodically dries up. The quartz sandstone is you would find that on a beach, right? Quartz sand, which then gets cemented into sandstone. Now this is really cool. Cross-bedded sandstone, where would you find that? Dunes, conglomerate, glacial deposits, that tends to be gravel, rock salt, salt flats, shale with fossil. A swamp is where you'd find mud, fossil-rich limestone, coral reef.